Hello everyone. In this module, we're discussing the empowering learners with multimodal contents in STEM education. This module basically focuses on giving an understanding of softwares and softwares for the AR, VR, and haptic integration in STEM education. As in the previous slides, we have discussed about the AR, VR, and haptics technology and their hardwares. So let's move on to the next slide. So as I have already discussed in this presentation, we will be discussing the integration of AR, VR, and haptic technologies using different software platforms like Unity, ROS, Gazebo, Unreal Game Engine. So these software tools allow developers to create immersive and interactive educational content that integrates multiple modalities such as visual, auditory, and tactile feedback. By leveraging the capabilities of these software platforms, educators can create engaging and interactive learning experience that facilitate the acquisition of knowledge and skills in STEM education. So, in the following slides, we will be discussing the features and capabilities of each software platform and how they can be used to integrate AR and VR haptic technologies in educational content. So there are most commonly used platforms like Unity, Unreal Engine, and ROS Gazebo. The first two, these are more focused on gamification and for the learning purpose, but the ROS Gazebo is more related for the research purposes for the robotics platforms. So these are the two different types and we are going to discuss. So the Unity and Unreal Engine are popular game development engines that offer powerful features and tools for creating immersive virtual environments. So these engines can be used to create 3D models, animations, and interactive scenarios that incorporate haptic feedback and other modalities. So Gzebo, on the other hand, is like a more robotic simulator that can be used to create simulation of a real world environments under robots. It offers realistic physics and sensor models which can be used to create realistic and interactive simulations of the robot and their environment. So this ROS Gazebo is basically more research oriented, and these the first two softwares are related to the gamification and educational purposes. So it is like more for the gaming purposes. So first, if we discuss about the Unity platform for educators and their gamification. So in this slide, we will be next on we will be discussing about how Unity platform can be used to create AR VR content for the educational purposes, and how which different AR VR headset are compatible with the Unity. So Unity is basically a very powerful software platform that offers robust tools and features for creating immersive and interactive AR VR experiences. With Unity, educators can create 3D models, animation, and interactive scenarios that incorporate haptic feedback with a range and other modalities. So, Unity is compatible with the range of AR VR headset, including the Oculus Rift, HTC Vive, Microsoft HoloLens, and many others. So, by discussing the capabilities of Unity and the different AR/VR headset that are compatible with it, basically, we aim to provide a complete knowledge for the integration of these headset with the Unity. So Unity, as we can see in this slide, Unity Hub, it is used for the project management, version management, add-ons and extension and templates. There are more templates and examples are available already in the Unity, and there are a lot of add-ons and extensions which we can use. So the two most commonly used AR/VR headset that can be integrated with the AR with the Unity or the Oculus Rift and HTC Vive. The best thing about that, they give us the head tracking, and they also have a hand controllers and many other VR features. So we can integrate them with the Unity. We can create our own environment, and we can get the feel of the learning, of the high quality learning. So this is the one way of doing this. So in the next slide. I will be discussing about how we can integrate this AR VR headset with the Unity. This is an high level flow diagram. As you can see, this is a high level flow diagram which basically tells us the steps of how to create or integrate these Oculus headset with the Unity. So first we need to install the Unity Hub. Then we have to install the Oculus software. Then we need to install the required Oculus integration packages. And in the Unity, after that, we can create our own 3D model of the simulation, and now import the Oculus package into the Unity. Now configure player settings, and after that, set up the Oculus camera, and now you can test the VR scene. So this is a high level or abstract level description of the flowchart of the integration of VR AR headset with the Unity. Now, in this Unity, we can create our own environments, and we can integrate this Oculus headset with that, and we can feel and we can get a very immersive experience. So this video tutorial is added basically, which tells us about the whole complete, you can say the steps or a guide. This is a whole tutorial. This is a whole 11 minutes video which will elaborate step by step that how the AR VR can be integrated with the Unity, and it is a very effective for those who want to learn and who want to do that by themselves. So I think this is a very good experience, the integration of AR VR with the Unity for the learners and for the educators. On the other hand, if we discuss as in the start, I have discussed about the two main categories. One was for the gamification and the education purpose, and other for the research. That is, ROS Gazebo is basically more research oriented. So this ROS, Robot Operating System, and Gazebo is a simulation software. So we can integrate AR VR headset with these. So this integration can enable the creation of highly realistic and interactive virtual environments for STEM education, and allowing students to explore and experiment with complex concepts and systems in a safe and controlled setting. So what we will do, we will first introduce the ROS and Gazebo, highlighting their key features and capabilities in the context of a STEM education. So we will then discuss the process for integrating AR/VR headset with ROS and Gazebo, which involves configuring the headset and its associated software to the work with the ROS, setting up a virtual environment in Gazebo, and creating custom plugins to enable interaction with AR/VR headsets. So ROS is basically used for testing and training purposes. So we can effectively interact with the robot in a real time. So it gives us the precise control of the complex system. So, for example, if students or educators want to learn about the robots and how they behave and how the human can behave with these robots or can interact with these robots, so AR VR is using with the ROS Gazebo is a very good platform. So we can create a real world simulation in a ROS Gazebo. So we can use Microsoft HoloLens and Magic Leap One. So these are the commonly used AR VR headsets that can be integrated with the Gazebo. So by this way, students can get a very high quality learning, and they can learn about the complex systems in a safe and a controlled environment. So at the end, this is another abstract level or high level flow diagram for the integration of HoloLens VR headset with the ROS Gazebo. So what we need to do first, we need to install ROS Gazebo, and then we need to install the HoloLens development kit. Then we have to create a package of a ROS. Then we have to set up a node, and then create Unity package, and then set up HoloLens headset. And after that whole integration, we can run our own simulation. Now, again, this is an abstract level and high level diagram. So there could be might more challenges while we will integrating these headset with the ROS Gazebo. So, but at the end, it's a very good experience doing this whole simulation and whole this learning experience. So, our main goal in this presentation was to give the idea of how we can integrate AR, VR, and haptics for the immersive learning, and we can create our own simulation environments, and we can work on that accordingly. Thank you so much.